Okay, so good morning, everyone. So I hope that you are all doing well, and may the blessings of our Lord be with you always. May He give you the strength, the knowledge, and the wisdom, okay, and the patience that you need to be able to cope up with all your subjects for this school year. So we are experiencing different adjustments due to our new normal situation. But with the grace of God, you can finish this whole school year without a problem. Okay, so I hope that you enjoyed the film or the short film that I showed earlier. So that is about the old TV show that probably you were watching when you were young. Okay, the Sesame Street. So I know that you know the basic properties of circle. So for today's lesson, we are just going to study, to have a deeper study on the different properties of circles bounded by its theory. So about the chords, the arcs, the central, and inscribed angles. Okay. So for the second quarter, we started off with the discussion about graphs. Okay, so that is a continuation of our chapter 2. Okay, and today we are going to have the introduction of geometry. Okay, so this is chapter 3. And basically, for the whole second quarter, we'll be studying geometry. Okay, so from today up to the remaining weeks of the quarter, we will be discussing geometry. Okay, for the third and fourth quarter, we'll be discussing probability and statistics. So I've chosen to show you the scanned copy of your book so we can discuss the different examples and explanations and theorems in your book page by page. Okay, so I'm going to start sharing the screen now. Okay, so we are going to discuss chords, arcs, and central inscribed angles in a circle. So for this chapter, in this chapter we do computational geometry instead of spending time improving theorems. So we have an adequate background in proving theorems in geometry in the previous levels, and you state the theorems and use them to solve related problems. So practically, this is the application, or these are the applications of the theorems that you learned when you were in grade 9 in geometry. Okay, now, the given figure is a circle with a center O. So this is a circle with a center O. As we all know, the center is equidistant from the points on the circle. Okay, so any points on the circle here around is equidistant, okay, from this point O. And the points on the circle are referred to as points of the circle. So if I'm going to have a point here, okay, so the distance from point O to this point is equal to the distance from this point O to another point here on the circle. Okay. Now, let us have figure 1. The two radii of the circle in figure 1 form an angle called central angle. Okay, so this is radius 1. Okay, and this is radius 2. We have two radius, we call that radii. So we have OA, the segment OA, and the segment OC. Note that the radii of a circle always intersect the center. Okay, so the radii of a circle always intersect at the center. If you're going to extend the line here and the line here, they are intersecting at the center called O, which is also the vertex of the central angle. Okay, so this is our central angle, and point O is our vertex. The size of the central angle, okay, angle AOC. When you name the angle, the vertex is always in the middle. So AOC. When you say AOC, we are referring to this angle. Contain the radii segment OA and segment OC of the circle. Also, the central angle AOC intercepts the minor arc. An arc is a part, section, or subset of a circle. So this is the minor arc. So this is the intercepted arc, we call it. So if this is your central angle, this is your intercepted arc. Okay? The measure of angle AOC. Let us go back here. The measure of angle AOC. Okay, so we are referring to this angle. Okay? The measure of angle AOC, where are we? And the measure of arc AC. So this is the measure of angle AOC and the arc AC. Okay, this is our arc AC are equal. As a matter of fact, the central angle and all arcs formed by corresponding points from the sides of the angle have equal measures. So if this is your central angle, intercepted arc is equal to the measure of the central angle. Definition: in circle, so we have the definition 1. Please do remember this. In a circle, the measure of a central angle equals the measure of the minor arc it intercepts. Again, the measure of the central angle is equal to the measure of the minor arc it intercepts. If this is 30 degrees, so your arc AC is also 30 degrees. A and C are the outer endpoints of radii OA and OC. Radii OA and OC, we now have a segment joining AC. And this segment AC is called a chord. Okay. So these are the central angle O. Let us go back to the parts of the circle. Central angle O, radii OC or radius OC, segment OA again. This is the central angle O. Segment OA as one of your radius, okay? And then OC, segment OC is another radius. And when you connect the 2 points, okay, this is also a segment. This is different from an arc. An arc, we denote that as, like that arc, that is with an arc like that, okay? But here, it is a straight line. So this is a segment connecting point A and point C. So that is segment AC. And that segment is what we call the chord. Okay. Another definition, definition number 2. A chord of a circle is a segment joining 2 points of the circle. So this is the first point here on the circle, point A and point C. Okay, so if you join 2 points on a circle, that is a chord. Question: is OA a chord? No, it's not, because your point O is not on a circle. It is here at the center of your circle. It is just lying around the circle. So your point A and point C are 2 points of the circle, and when you join them, that is a chord. We can draw chords in a circle of varying lengths. In the following figures, we draw congruent chords to determine regular polygons. So what are the chords here? This one is a chord. 1, 2, and 3, giving us the so 120, 120, 120, 360 equilateral triangle. Because if this is 120, 120, 120, then that is an equilateral triangle. And here we have quadrilateral, okay, square, 90, 90, 90, 90. Where are the chords here? 1, 2, 3, and 4, and 5. That is also a chord, okay, because you are connecting a point there and a point here at B. Okay. Here we have 1, 2, 3, 4, 5. It is a pentagon. Okay, so how many chords do we have? 1, 2, 3, 4, and 5. Okay. And here we have 1, 2, 3, 4, 5, 6. We have 6 sides, so we have hexagon. So for an equilateral triangle, we have 120 degrees from the central angle. If you divide it by 3, from the central angle, if you're going to draw or to inscribe a quadrilateral inside the circle, so you have 90 degrees each, okay? And then, if it is a pentagon, so you divide 360 by 5, giving us 72. And if you are going to inscribe a hexagon, we have 60 as one of the angles, okay? In figure 3A, we have 3 central angles measuring 120 degrees each. So what I said earlier. And so we inscribe an equilateral triangle, which is a regular triangle. So these are the explanations earlier. So if you're going to describe a parallelogram or a quadrilateral, so each angle is 90 degrees from the central angle. If it is a pentagon, so we have 72 degrees each. And for hexagon, we have 60 degrees each. Okay, so congruent chords of a circle are equidistant from the center of the circle. So if they are congruent, they are equidistant from the center of the circle. Say for example, this one, this is equidistant 1, 2, and 3. Okay. So these are also equidistant 1, 2, and 3. We also have this. These are equidistant from each other. Okay. And then this one as well. Okay. And this one. Now, let us have this example. We know that all the triangles formed by the two radii and the chord of inscribed polygon are congruent isosceles triangles. The altitudes from the vertex angles to the corresponding bases, which are also the chords, are congruent. Say, for example, figure 4, we have now chords AB, 1, and BC. So these are both chords because we are connecting 2 points on a circle, intersecting on the circle at B. Okay, we have 2 chords intersecting at point B. Okay, so this is the chord 1 and this is the chord 2. We have another angle form called inscribed angle. So this is another angle called inscribed angle. So in figure 4, this is figure 4, angle ABC is an inscribed angle, meaning to say that the angle is inside the circle. Okay? So angle ABC, again, when you are naming the angle, the vertex should be the letter in the middle. Okay? So we have vertex at B, that's why it is angle ABC. Okay? It's an inscribed angle. It contains the chords AB, this one. Okay? And the chords BC, this one. Okay? Both the inscribed angle ABC, okay, and the central angle AOC intercept the same arc. So they have the same arc. Okay, again, ABC, so this is one of the angles. This is the intercepted arc for ABC. But if you're going to look at this, angle AOC has also the same intercepted arc AC. Okay, how are their measures related? So the measure of angle AOC is equal to the measure of angle AC, of arc AC. It's from our theorem earlier, we know that the measure of the central angle is equal to the measure of the intercepted arc, right? So if this is 60 degrees, we have 60 degrees. But how are we going to get the measure of another inscribed angle with the same intercepted arc? So, to measure the inscribed angle with the same intercepted arc as that of the central angle, we get half of it. So, if this is 60 degrees, this is 30 degrees. Since they have the same intercepted arc, so the measure of this angle is half the measure of the central angle. Okay? So, let's have, this is theorem 1.2. The measure of an inscribed angle in a circle is half the measure of the arc it intercepts. And in a circle, inscribed angles that intercept the same arc or congruent arcs are congruent, of course. So all the arcs mentioned above are minor arcs. So this is an example of a minor arc. Since the measure of central angles are less than 180 degrees, then it follows that the minor arcs that angles intercept are also less than 180 degrees. Okay? Let us have this figure 5. The circle figure 5 shows the central angle AOC. Again, AOC. And then measuring 60 degrees. So it has a minor arc. This is the minor arc, which is also 60 degrees. Okay. In the same figure, there is another arc in the circle that connects A to C and passes through B. So it is connecting. If you are going to look at this, you are clockwise. This is a clockwise connection. So A to C, this is a minor arc. But if we're going to go the other way, counterclockwise, we also can see the connection between A and C, but it is passing through B. So this case, 1, 2, 3, it passes through B, going to C. This is another arc, and that is what we call the major arc. Okay? We name this bigger arc as arc ABC, or the major arc ABC. And the combined measures of two arcs, the minor arc and the major arc, is 360 degrees. Of course, if your central angle, the totality of it is 360 degrees, your inscribed angle or your arcs, okay, the total measure of your arcs, both the minor and the major arc, is also 360 degrees. Hence, the measure of the major arc is equal to 360 minus 60 is 300 degrees. So this is 60 degrees, the minor arc AC, and the major arc ABC is 300 degrees. Okay, so if the whole circle is composed of only two arcs of equal measures, then each arc is called semicircle. Meaning to say, the measure of a circle, of a semicircle, is 180 degrees. Take a look at this. We have the chord AB. So if you are dividing the circle into two equal parts or into two equal measures, this chord is the diameter of the circle. So diameter is a chord, but this is the longest chord. Okay, so in figure 6, so this is our figure. Major arc AED is equal to arc AFD. So these are semicircles. So let's have theorem 1.4. In a circle, a inscribed angle that intercepts a semicircle is a right angle. Again, in a circle, a inscribed angle that intercepts a semicircle is a right angle. This is one of the example. So this is a semicircle. We have two semicircles, 1, 2, okay? Meaning to say, the measure of this is 180, and the other one, this arc, is also 180. So this is your diameter, your longest chord. So the angle that it intercepts, so this angle is equal to 190 degrees. Why? Do you remember earlier in one of our theorems that the inscribed angle is half, okay, half the measure of the inscribed angle or the intercepted arc. Again, the measure of the inscribed angle is half of the measure of the inscribed or the intercepted arc. And what is the measure of intercepted arc? Since our central angle is 180, our intercepted arc, AD, is also 180. And what is 1 half of 180? That is 90. Okay. Let's have in figure 7, angle AED intercepts in semicircle AD, okay, whose measure is 100 degrees, hence the measure of AED. AED is 90 degrees, okay. Let's have figure 8. In figure 8, PQRS are points on the circle 1, 2, 3, 4. And how many chords do we have? 1, 2, 3, and 4. They are the vertices of an inscribed angle that intercepts their corresponding arcs. Okay? This makes quadrilateral PQRS as an inscribed polygon. So this is a polygon, okay, inside a circle, okay, and uh, where angle P intercepts RQRS, where angle P intercepts RQRS. QRS, so this is the intercepted arc. This is your angle P, okay, and this is your central angle. Now, and Q intercepts RSP. Q intercepts arc RSP, and angle R intercepts QPS, and angle S intercepts PQR. Okay, if measure of angle P is equal to x, and measure of angle R is equal to y, then x plus y, okay, then x plus y is equal to 1/2 of the measure of QRS plus 1/2 of the measure of SPQ. Okay, let us try to make it a bit smaller so we don't have to go up and down. Let's make it 100. Okay, a bit lower, 75. Okay, so we have the whole view. So in figure, x plus y, this 1 and 2 is equal to 1/2 of the measure of QRS. This one. 1/2 of the measure of QRS plus 1/2 of the measure of SPQ. SPQ. Okay? Why? Diba alam natin na kapag itong iyong intercepted arc, itong iyong angle, kalahati siya ng intercepted arc. Tama? So, kalahati nito, ito yon, measure of QRS. Kaya 1/2 ng measure ng QRS. Kung ipa-plus mo to, kalahati din ito. QPS. Okay? Or SPQ. So, it's the same thing. So, that is equal to 360. 1/2 of 360 is equal to 180, which is correct. Tignan nyo, supposedly this is 90, right? Kasi this is a right angle. And this is your central angle. So, 90 plus 90 is equal to 180. So, opposite all angles of quadrilateral inscribed in a circle are supplementary. Since 90 plus 90 is equal to 180, when we say supplementary angles, the sum of two angles is equal to 180 degrees. Okay? And for complementary, the sum of two angles equal to 90 degrees. So, if we draw the diameters, we determine congruent central angles. Okay? So, these are two diameters, 1 and 2. Okay, these central angles intercept congruent arcs. Okay, so what are the central angles? So, this one and this one, they intercept congruent arcs. So, in figure 9, angle AOC, so this angle, okay, equals the measure of arc AC, of course. So, because this is a central angle, so the measure of central angle is equal to the measure of its intercepted arc. The measure of angle AOC and BOD are equal. This is equal to this. They are vertical angles. Okay? Hence, the measure of arcs AC and BD are also equal. In the same figure above with chords AC and BD, so here AC and BD, since they are equal, of course your chords here are also congruent. Okay? And then we have a triangle AOC, the whole triangle, this one, is equal to or congruent to triangle BOD by side, angle, side. Side, angle, side. Okay? Postulate. Hence, chords AC, this one, is also congruent to chords BD. Since AC and BD have equal measures, it follows that congruent chords have congruent arcs. Conversely, congruent arcs have congruent chords, of course. So, if your chords are congruent, these are congruent, okay? Congruent because this is central angle. So, your arcs are also, the intercepted arcs are also congruent, okay? Adjacent central angles determine the adjacent arcs. So we use angle addition postulate to determine the sum of the measures of these two adjacent angles. So what is this angle addition postulate? In figure 10, measures of angle or of arc PTG, this arc, is equal, PTG is equal to the measure of the arc PT plus arc TG. So, in simple words, ito, ang kabuang ito ay pag pinaghiwalay mo ito plus ito at saka ito, pagsamahin mo sila, itong buong to. Okay? Let us do some computations. Find the measures of central angles, inscribed angles, and arcs. By the way, when you say inscribed, the figure or the angle is inside a circle. But when you say circumscribed, your circle is inside a polygon. Okay? So, let us have example 1. So, what is the measure of angle JOG? So, this angle, so it clearly says that it is 57.5 degrees JOG. Okay? And the measure of angle JOT, since this is supplementary, 180 degrees, so you have to subtract 57.5 from 180, giving you 122.5. So again, this JOT is 122.5. Measure of angle JG is 1, is equivalent to this one, 57.5 degrees. And measure of angle JT is equal to 122.5 degrees. Very easy. Let's have number 2. Okay, example 2. So we have the measure of RON. This one. So your arc, the measure of your arc is given. The measure of your arc N is given as 136. Okay. So the measure of your angle RON is equal to 136 as well. Now let us have the measure of RAN. RAN. Okay. So the measure of angle RAN is 1/2 of the measure of arc RN. Why? Because the intercepted arc of your RAN, this angle, so this is the intercepted arc. The intercepted arc of your angle RAN is also the intercepted arc of your RON. So since your intercepted arc is 136, your inscribed angle is half of the measure of the intercepted arc. So 136 divided by 2 is 68. Yes, correct. Now, what is the measure of the major arc, RAN? Since this is 136, all you have to do is to subtract that from 360, giving us 224. Now, let us have example number 3. Okay? So, for example number 3, we have the measure of angle SIT. So, it's very clear. It's 90 degrees. Okay? And then the measure of TSI. Okay? TSI. So, this angle, if this is 90, this is 35, all you have to do is to subtract them from 180. So, TSI is equal to 180 minus 90 minus 35, giving us 55 degrees. So, 35, 55, 90. And the measure of SET is, of course, 180 because this is a semicircle. The central angle is 180, so your semicircle is 180. And the measure of arc SI. The measure of arc SI, okay, this one. So you have to multiply this by 2 because you know that if the given measure is the arc, to get the measure of the inscribed angle, you divide this by 2. So if the given measure is the inscribed angle, to get the measure of your arc, you multiply by 2, gives you 70 degrees. And the measure of IT, this one, so that is 180 plus 70. Okay. So, what is the measure of your IT? So, this is 110. So, you have to subtract from 360. Okay. So, measure of IT. So, you have here 180 plus 70. So, that is already 250 minus 360. So, this the minor arc IT is equal to 110 degrees. Let's have example 5. Okay. So, we have x plus 20 plus 4x. So, these are the arcs. X plus 20 plus 4x plus 5. Okay. Plus 3x plus 15 is equal to 360 degrees. So, finding the value of x. So, 20 plus 5 is 25. Plus, plus 15 is 40. Okay, so 360 minus 40 is 320. And then we have 5x plus 3 is equal to 8x. Okay, so x dividing x is equal to 340. So we know that x is equal to 40. 40 plus 20 is 60. And then 40 times 4 is 160 plus 5. And then 40 times 3 plus 15. Add them all, it will give you 360. Okay. The measure of JG, so 40 plus 20. Okay. And then the measure of angle JOG, okay. That as well is 60 degrees because your minor arc is 60. Now, the measure of GN is 40 times 3 is 120 plus 15 is 135. So, GON, which is the central angle, is equal also to 135. And the measure of JN is equal to 40. 4 times 40 plus 5. So, this is 165. Okay? Because your central angle, your minor arc is 165, your central angle is also 165. Okay, moving on, we can draw two diameters of a circle that obviously intersect at the center of the circle. Then we draw chords to form two triangles as in the figure 11. Okay, so let us check this. Okay, so let us have figure 11. The triangles in the circle at the left are congruent. Okay? So, this triangle is congruent to this triangle. In the circle at the right, angle DAC. Nasaan yung DAC? Ito yon. DAC, ibig sabihin yung gitna, ito yon, is, and DBC, kasi natin DBC are also congruent. So, ibig sabihin, itong angle A at angle B ay congruent. Okay? Similarly, angle ADB, okay, ADB, ito yon. Ayan. Congruent din siya sa ACB. Ayan, yung angle D is congruent to angle C. Okay? Now, thus, since they have the same intercept, tingnan natin to. ADB, pareho lang ang intercept niya ni ACB. Tama ba? Tingnan niyo to. ADB. Ito ang kanyang intercept. Itong kay ACB, ito rin ang kanyang intercept. Kaya, pareho ang sukat ni D at saka pareho ang sukat ni C. Tingnan natin kay A. Itong angle A, ang kanyang intercept ay itong CD. Tama? Ang intercept ni B, angle B, ay ito ring CD. Arc CD. Kaya yung angle A mo ay kapareho ng measure ni angle B. Okay? And we can say, therefore, AE, okay, AE, nasa natin AE, and BE, okay, is equal to DE and CE. Okay? So, AE and BE is equal to DE and CE. Okay? Ratio and proportion yan. Okay? And AE, okay, AE to CE is equal to, multiplied by C is equal to BE multiplied by DE. Okay. So, if two chords of a circle intersect each other inside the circle so that each chord is separated into two segments, then the product of the lengths of the segments of one chord is equal to the product of the lengths of the segments of the other chord. So, himayin uli natin yon. Tingnan nyo ito. Di ba ito, AE. AE, okay, kapareho siya ni BE. Okay, AE, BE, ayan. Yan siya. A is to BE. Kaya yung DE, ito yon, is to CE. Siya yan. Okay, yun. 1, 2. Okay, by ratio proportion, to multiply the mean and the extremes, AE multiplied to CE is equal to BE multiplied to DE. Okay? The means and the extremes, we call that. So, determining the missing links in the following examples. Tulad nito. 9 times x is equal to 6 times 6. Okay? So, 9x is equal to 36. So, what is the measure of x? X is equal to 4. Supposedly, there is 6 there. Okay? So, x is equal to 4. Let us have this example. Number 2. This one, 1.5 times x, okay, is equal to 3 times 3.5. Finding the value of x gives us 7. Example 8, 3x times x is equal to 6 times 2x. So, we have 3x squared is equal to 12x. So, simplifying, 3x squared is equal to 12x. So, 3x squared minus 12x is equal to 0. Going back to the equation that we have in the previous lessons. So, we equate this to 0. And then we find the roots. Okay? So, get the common factor. What is the common factor of 3x squared and 12x? So, both of them have x and divisible by 3. So, the common factor is 3x. 3x squared divided by 3x is 4, and negative 12x divided by 3x is negative 4. Okay? So, 3x is equal to 0 and x minus 4 is equal to 0. So, x is equal to 0 and x is equal to 4. We will not use 0 because that is a distance or length. Hence, the value of x is equal to 4. Okay? We have two values. To make it clearer to sum, we obtain two values of x. When you have quadratic equation, you have two values of x. But since we are dealing with length or distance, there is no 0 or there is no negative. Both of them, 0 or negative, we do not have 0 length or negative number for lengths. Okay? That's why we're going to get the other one, which is equal to 4. Okay, when two chords of a circle intersect at the interior of the circle, each angle formed is related to the intercepted arcs. Okay, let's have this. What is the measure of angle A, given that we have the measures of the intercepted arcs? So, to get the measure of angle A, we have to add the measure of the intercepted arcs divided by 2. Okay? So, if two chords of a circle intersect at the interior of the circle, the measure of the angle or its vertical pair is half the sum of the measures of the corresponding intercepted arcs. Let us put that in example. Example number 9. In figure 12, A is equal to 73 and x is equal to 51. So, what is y? If A is equal to 73 and x is equal to 51, what is the value of y? Using this formula, A is equal to 1 half x plus y. So, A is 73 is equal to 1 half 51 plus 1. Okay, so you multiply this by 2. Okay, or 2 times 73 is 146. Giving you 1 times 51 is 51, 1 times y is y. Okay, so you have to transpose 51 here and leave y to find the value of y. So, 146 minus 51 is 95. So, we say that y is equal to 95 or the value of y is equal to 95. For this intercepted arc, this is 95. What is our x plus 51? 95 plus 51 is equal to 140. Ilan ba yan? 51 plus, ilan nga tayo kanina? 51 Ang ating x ay 51, ang ating 1 ay 95, 146 divided by 2, giving us that a is equal to uh, 73. Okay? Tama ba? 51 plus 95, 146, tama, 73. 70, and then 6 divided by 2 is 3, giving us 73. So, this is correct. Okay, so remember a central angle of a circle is an angle whose vertex is the center of the circle and whose sides contain the radii of the circle. The measure of a central angle equals the measure of the arc it intersects. An inscribed angle in a circle is determined by two chords intersecting on the circle. The sides of the inscribed angle contain the chords of the circle. And the measure of an inscribed angle equals half the measure of the arc it intersects. And a minor arc measures less than 180 degrees. A semicircle measures 180 degrees, and a major arc measures greater than 180 degrees. So if it is less than 180, that is a minor. If it is 180, that is a semicircle. If it is greater than 180, then that is a major arc. If two chords of a circle intersects each other inside the circle so that each chord is separated into two segments, then the product of the lengths of the segments of one chord is equal to the product of the lengths of the segments of the other chord. And if two chords of a circle intersect in the interior of the circle, the measure of an angle or its vertical pair is half the sum of the measure of the corresponding intercepted arcs. Okay, so that is the end of our lesson 2 for second quarter. So this our lesson that we discussed earlier. It's all about the chords, the inscribed angles, and the central angles. So we put into application the theorems that you studied when you were in grade 9. Diba may mga proving kayo doon ng identities, sa geometry, sa mga SAS, ASA, SSS. So, yan, dito nyo na i-apply sa geometry dito. Kaya nga, yun kasing ating curriculum for K-12 is spiral progression. Meaning to say, continuous yun, tigkakaunti, and then, nadideepen, kaya paikot siya, nadideepen siya as you grow, as you go in higher years. Okay, so, what values can we get from this lesson? Okay, so, the value for me from this lesson is that life is like a circle. Okay, ang buhay ay parang isang gulong. Sometimes you're on top and sometimes you're at the bottom. But what should remain in you, whether in your top or you're at the bottom, is your respect to everyone. So I would like to emphasize the word respect. So when you are enjoying life, when you're enjoying your success, when everything in your life is going well, okay? So you still have to respect not only the people with titles or not only the people who are in the same group like you or with you, but even the people who are below you in status. Okay? So, sa buhay kasi, hindi mo malalaman kung kailan ka nasa taas, kailan ka nasa baba. Because, well, even if you're working hard in life, there are circumstances in life that are external or not because of you, but they are just circumstances brought by the outside world. So, let's say, ikaw ay hard worker, ang sipag-sipag mo, and you're doing everything, but because of the pandemic, look what's happening right now, hindi mo ito katamaran kaya ka nawalan ng trabaho. Because there are things that are uncontrollable, beyond your control. Okay? So, whether you're on top or you're at the bottom, you should always have respect. Kasi kung ikaw ay minsan nasa taas, but you know how to respect people, you know how to respect the feelings of people, and there comes a time na ikaw ay maging nasa baba because of reasons that uncontrolled o hindi mo kayang pigilin. Ang tao ay hindi, alam mo yung iba yung pagtingin sa'yo, hindi yung sasabihin sa'yo, ang yabang kasi kaya nagkaganyan. Okay? So, and when you are still at the bottom, respect mo din yung feelings ng mga, let's say, not everything is doing well with you. Ikaw ay nahihirapan sa buhay, ang dami-daming problema, so nagiging mainit ang ulo mo, nawawalan ka na ng respeto sa mga taong nakapalibot sa iyo. Wala ka na ng respeto sa feelings or emotions sa mga tao nakapalibot sa iyo. You're so centered sa iyong pain. You're so centered in your failure na you're blaming everyone. That is what we call yung, ano ba tawag, yung parang attribution theory. When everything is doing well with you, you're attributing that to yourself, but when everything is falling, you're attributing that to the outside world. Okay, so lahat sinisisi mo sa mga nangyayaring pangit sa iyo at hindi mo na iniisip ang na damdamin ng ibang tao. Okay, so you will never know na you will need them. And even if you are well off in life, you will need them. Hindi sa lahat ng pagkakataon, ang kailangan mo lang ay tao na mas makapangyarihan or tao na ka-level mo. Modesty aside, I would like to share my perspective in life with you. Modesty aside, I never boast that I am the principal of the school because for me, title is just a title. Doesn't mean anything. Probably sa hierarchy sa school, yes. But still, I am just like the teachers, your teachers, okay? So, because I learned a lot in life na uh, there are more in life than titles. I mean, the true essence of life is not what you have achieved, okay? But the true essence of life is that how many people have you touched, okay, in your whole life? Ilan ba ang ikaw ay naging inspirasyon? Ilan ba ang tao na natulungan mo? Ilan ba yung tao na naniniwala na ikaw ay mabuting tao? So that's really the essence of life. And being good or being a better person is not because we have the title, but being a better person is how we live our life, how we understand the interdependence of people and the interdependence of the creation of God. Okay, so I never, even in my Facebook, I never say I am the school head. I even on my table, you won't see na meron ako naka-engrave na pangalan na high school principal. Kasi sabi ko nga, though I work hard for this title, but for me, it's meaningless if I do not do my job faithfully and if I do not serve my brothers and sisters using my position. Okay, so uh, what I'm trying to tell you is that you have to respect everyone, regardless of your position in life, regardless of your status in life, whether you're on top or at the bottom. Okay, and do not let the wealth that you have, the power that you have, the position that you have, to forget the word respect. Kaya nga, naalala nyo nung tayo ay nasa campus, nagagalit ako kung binabastos nyo ang security guard, kung ano-anong inuutos o kung hindi maganda ang pagtrato nyo kay Kuya Wally, kay Ate Sally, kay Kuya Riden. Kasi these are the people who are helping us. Although we can say that they are utilities, okay? So sila ay hindi mga guro, still ang title ay hindi siya isang what do you call that? It's not the title that makes us respect other people. Okay? So for your assessment for this lesson, let me go back to our structured daily learning plan. So for today, we had our video, and later on, we're going to have our synchronous learning session through our Google Meet. And then tomorrow, day 2, you are going to answer classwork exercises, pages 151 to 152, even numbers only. And then, okay, let me check the book, 151 to 152, yes, even numbers only. And the practice exercises, okay, on day 3 to day 4, practice exercises, pages 153 to 155, meaning to say, numbers 21, 22. Oh, sorry, these are odd numbers. Number 21 is not included. So, up to number 19 only. So, you have to answer that for 2 days. So, I will give us that as to do on Thursday. So you have to do that until Friday and make sure to answer the question page of Weeper because that serves as again your quiz, and submit your solutions through your Google Classroom or Dropbox. Okay, until November 9, both the solutions for even number for classwork exercises and the solution for practice exercises. And do not forget the self-assessment tool found in your learning packets if you have the learning packets, or the link in your Quipper. Okay, so I hope you learned a lot from our today's lesson. And all your difficulties, if you have gray areas, you have the chance to ask me later in our Google Meet. Okay? So make sure to ask questions if you do not understand the lesson. Do not be shy in asking questions. Okay? Some students are sending me messages. Okay, you can send, but I cannot assure you that I can answer immediately, because although I am online all the time, sometimes I'm not on my desk, or sometimes I am doing other tasks that I cannot be disturbed because of the lot of administrative things that I have to do. So if you're getting stuck, or if you have questions, all you have to do is to ask me. And if your questions is in LMS, do not finish what you have in LMS, okay? And ask me first before you continue if you have problems, okay? So thank you for staying with me today. I hope that I contributed in the fountain of your knowledge. And I hope that everything that you're learning from our subject, from the discussion up to the valuing, you will remember that. And especially those who will be getting engineering related courses, okay? So these basic principles, or these theorems about circles, the chords, the inscribed angles, and the central angles, all of these will be a great help if you have a great knowledge, if you have knowledge in all these theorems. This will be a great help in your geometry when you pursue engineering related courses. Okay, so, and I hope you remember as well, one of the important parts of our session for today is our valuing. Okay, so thank you very much for staying with me. I know that you're seeing BTSB at the back, yes. Okay, so he's part of my room. Okay, and may God bless you all until our next session. Thank you very much.